The video shows the solution to the second example of combined inequality. Welcome to Mathematics of Engineering. There are 5 types of inequalities, the first one of which is linear. By the name, the degree of inequation is 1, which means the exponent of the variable is 1. The second type is quadratic, which has a form where the variable x is squared. The third type of inequality is rational, which has the form with a denominator, analogous to a rational function. The fourth type of inequality is compound, which can come in 2 different formats. The first format contains 2 inequalities connected by and or or. The second configuration of compound inequality is a series of inequalities connected by 2 operators. The last type of inequality is absolute value, which includes a modulus. Each of these types of inequalities has a distinct operation to get solved. The second example includes the inequality of 4 times the absolute value of 2x plus 1 all over x less 1, and this is less than or equal to 12. A little tweak from the first example, but we check the impact of a minor change in the inequality. Analyzing the inequation, the denominator depicts the procedure of rational inequality. Then, the modulus in the numerator shows absolute value inequality. Starting from the denominator, which should not be equal to 0 to avoid creating an indeterminate form. X then should not be equal to positive 1. From the numerator, 4 of the absolute value of 2x plus 1, divide the numerator by 4 to clean up the expression. The division then makes the absolute value of 2x plus 1 is less than 12 over 4 or 3. Since we already reached the step of simplifying the absolute value, we then convert the modulus from the definition of absolute value. From the example, 2x plus 1 is less than or equal to positive 3. Then also, the same binomial of 2x plus 1, this time inequated to negative 3. Subtract 1 on both sides and have 2x as less than or equal to 2. Take out 2 from x by dividing everything by 2, leading to x as less than or equal to 1. From the other inequality, subtract 1 again on both sides and come up with 2x is less than or equal to negative 4. Divide both sides by 2 and have x as less than or equal to negative 2. Although there are 3 solved markers, the number line will only show 2, and those markers are negative 2 and positive 1. Because the original inequation is connected by less or equal to, both dots from the number line are filled. Having reached the number line and identifying the markers, we can proceed with the test. From the leftmost part, which is range from negative infinity to negative 2, we assume x as negative 5. The inequation then is 4 times twice of negative 5 plus 1 all over negative 5 minus 1. Simplify and have 4 times the quantity of negative 10 plus 1, which is then taken as 4 times the absolute value of negative 9 as equated to 12. The numerator can then be further simplified. 4 times the absolute value of 9 all over 6, which results to 6, and 6 is less than 12. Thus, this is a true statement. From the middle range between -2 and +1, we use 0. Plug these into the function and get 4 times of 0 plus 1 all over 0 minus 1. Simplify the binomials in the modulus and have 4 times of the absolute value of 1 all upon -1. The absolute value of 1 is still 1, so the inequation is 4 times 1 all over -1. This is then equal to -4, and this is indeed less than 12. From the last range, between +1 to +infinity, assume x of 2. Substitute 2 to all x in the inequation, and have 4 times the absolute value of 2 times 2 plus 1 all over 2 minus 1. And this expression is less than or equal to 12. The terms inside the modulus are simplified as 5, and the absolute value of 5 is still 5. So the inequation becomes 4 times 5 over 1. This is then computed as 20, which is not less or equal to 12. So from the test, we can observe that the range of answers for this are -infinity all the way to +1.